Hi, I'm Phoenix. I just finished my freshman year of college and I took AP Calculus my senior year of high school. So today, if you want to do the work with me, the worksheet and the answers are linked in the description below. And today we're going to practice derivative rules. Let's get started. Number one is a product rule derivative question. And so we will get f prime of x equals 5 to the x times ln of 5 times g of x plus 5 to the x times g prime of x. So that's just a simple product rule question. So for number two, it is a chain rule question, and I didn't do this when I wrote it out, but I would rewrite this as gx with brackets squared, just to make doing the beginning part easier. So imagine we rewrote it, and then you would get f prime of x, sorry, my hand is way in the way, equals 2 times g of x times g prime of x. So here's just a simple chain rule question. Okay, so moving on to number three. Here we do the chain rule for the first part, so we get f prime of x equals g prime e to the x times e to the x plus 5, which is the derivative of 5x. And here I just want to point out that the chain rule, when we do the chain rule, we multiply by the derivative of the inside function. So when you get f prime of x equals g prime of e to the x, and then the derivative of e to the x is e to the x, so you're multiplying by the derivative of the inside function, and that is how you do the chain rule in this case. And then at the end, this is a separate function altogether, so you just plus 5, because that's the derivative of 5x. Okay, then number four, another chain rule question. And so we will end up with f prime of x is equal to 1 over g of x times g prime of x. So here, the derivative of ln of something is 1 over, so 1 over g of x, and then times derivative of the inside function, which is g prime of x. Okay, so now we're to number five. Number five is also a chain rule question, and so we will get, so I forgot to write f prime of x, so there we go. Okay, so f prime of x is equal to g prime of x squared plus x, and then times the derivative of the inside function, which is 2x plus 1. And be careful here with the parentheses around the 2x plus 1. You want to make sure you have those there. Okay, so for number 6, this is also a chain rule question, so we'll get f prime of x is equal to g prime of g of x times g prime of x. 7 is another chain rule question, so we get f prime of x is equal to negative cosecant g of x cotangent g of x times g prime of x. So we move this. And here I just wanted to point out that, as you can see, when we did the derivative of cosecant x, that derivative is negative cosecant x cotangent x, and then we leave the g prime of x in place of the x, and then we'll multiply times the g prime of x in the end. And then for number 8, we will get another chain rule question, so we get f prime of x is equal to g prime of tan x times secant squared x. And the derivative of tan x is secant squared x, so that is how we get this answer. Okay, so for this next set of questions, we're going to be doing the same thing that we just did with the first 8 questions, but we're going to plug in numbers using this table. And using the table may seem simple, but some people find it tricky. So we'll go back and forth and reference the table as we solve these next few problems. Okay, so getting started with number 9. Eventually. Okay, so first we're going to take the derivative of 2 f of x plus 3. And so when we do that, we will get 2 f prime of x. And then we're going to plug in the 2. So we get 2 f prime of 2. And then we plug in and get our answer. So we get to the plug-in part. So we have 2 f prime of 2. So we'll go to the table and find what f prime of 2 is. And here we get 2. So then we plug it in and get 2 times 2, which equals 4. Okay, so then moving on to number 10. This is a product rule question. So we will get f prime of x times g of x. So here the same thing, we're going to take the derivative first, just of the function. So we get f prime of x times g of x plus f of x times g prime of x. And then we're going to plug in the 3. So we will get f prime of g times g of 3 plus f of 3 times g prime of 3. And so then we will plug in the numbers. 4 times 2 pi plus 3 times 5. And so just to go back and show how we got from here to here. So we'll go look for what f prime of 3 is to plug in. And then f prime of 3 is negative 4. G of 3 is 2 pi. F of 3 is 3. And g prime of 3 is 5. So that's how we get here to the negative 4 times 2 pi plus 3 times 5. And then we will end up with the final answer of negative 8 pi plus 15. Okay, and then for number 11, this is a chain rule question. And here we go. We will get, first we're going to take the derivative like we did the past two. So we get g prime of f of x times f prime of x. And then we're going to plug in the 3. So we'll get g prime of f of 3 times f prime of 3. And here, so technically we haven't filled in for the g prime yet, but we have to find what f of 3 is first before we can find out the numerical value of the g prime of whatever f of 3 is. So then we will get negative 4 times g prime of 3 as our next step. So how we did that was we found that f prime of 3 is negative 4. So that's where we get the negative 4 in the front. And then f of 3 is 3. So then we end up with g prime of 3. And then we get negative 4 times 5. And the 5 comes from the g prime of 3. And if you look, g prime of 3 is equal to 5. So we will end up with the final answer of negative 20. And then for our last question in this column, number 12, we will first rewrite it. So we're going to rewrite it as g of x to the negative 2 instead of how it is written now as 1 over gx squared, because this will make doing the question a lot more simple. And then the answer we'll get when we take the derivative first is -2 times g of x to the -3. And so this is a little tricky because we are using a negative exponent, and then we'll multiply times g prime of x. And then just like we've done for the past few questions, we will plug in the 3 now to this function. Adjust this so we can see the whole question. So we're going to plug in, so we'll get when we plug in, we will get -2 times g of 3 to the -3 times g prime of 3. And then that, when we look up at the table, we will get -2 times 2 pi to the -3 times 5, which is, can't really see it. Let's see if we can adjust this so we can see the answer. There we go. So your final answer will be -5 over 4 pi cubed. And if it's a little confusing how we get there, so the 2 pi cubed will move to the denominator since it's a negative exponent. And so the answer that we got, that we simplified to -5 over 4 pi cubed, was -2 times 5 over 8 pi cubed. And then when you cancel out the 2 and the 8, you get -5 over 4 pi cubed. And for this one, you couldn't really see the table, so it was hard for me to explain how we got all of these answers. But g prime of 3 is equal to 2 pi. That's where we got that. Or g of 3 is equal to 2 pi, sorry. And then g prime of 3 is 5. And so we plugged those in and got those values from the table that is above. So you would reference that to get those answers. Okay, moving on to number 13. This is a pretty simple derivative, so we will just get f prime of x minus 5g prime of x. And then we'll plug in the 3 after we write this out. And we will get f prime of 3 minus 5g prime of 3. So then we'll get -4 minus 5 times 5. So again, to get from here to here, f prime of 3, look at the table, f prime 3, -4 minus 5, you get that from the original, and then g prime of 3. So g prime of 3 is 5. So 5 times 5, and then you end up with -29 as your final answer. So then for number 14, it's the same process. We will first take the derivative. This is a quotient rule question. So to do quotient rule, you do high d low minus low d, or in this case, it's low d high minus high d low. It's a little switched up, but the quotient rule is low d high minus high d low over low squared. So that's how we got from here to here to take the derivative. And then we will plug in again g of 2 times prime of 2 is g prime of 2 f 2 over, you get the idea. And so once we have this answer, we will then use our table once again to plug in for the numerical values. So I'll have this get written out, and then I'll show you how we got there. So here we'll get fg of 2 is 1/3, g of 2, 1/3, f prime of 2 is 2, prime of 2, 2. G prime of 2 is -3 here. F of 2 is 8. And then G of 2 again is 1/3 squared. So we get this number, or this fraction thing, and then we will end up with the final answer of, well, I guess it cut out of the video, but the final answer for this one is 222. And so there are a lot of steps that it takes to get from this weird fraction thing to the answer 222. But you need to simplify and just get rid of the fractions to simplify it, and then you'll end up with your final answer. Sorry you can't see it. See if it ever. Okay, yeah. But answer 14 is 222. Okay, so now we're on to number 15. And so our first step here is going to rewrite it so that the next part will be easier as f of x to the 1/2 instead of the square root of f of x. Those are the same thing, we're just rewriting it. And so when we take the derivative, we will get 1/2 times f of x to the -1/2 times f prime of x, because of the chain rule. And then we will plug in, and then so here, f of 2 and f prime of 2. Sorry, it's a little messy. I ran out of room, but get the idea. This is all, I moved down, but it's still the same part of the question. And then after that, we will plug in and get 1/2 times the square root of 8 times 2. And our final answer will be 1/the square root of 8. So it's a little hard. Let's go back a second to see table. So here we have to find f of 2 and f prime of 2. So f of 2 is 8, f prime of 2 is 2. So that is how we get this and this. And those 2's cancel, so we just get 1/the square root of 8 as our final answer. So now for 16, the last question on the front page of the worksheet. First we'll take the derivative. It's just a simple derivative again, so 5 times g prime of x minus 2x. Then we'll plug in the 2, 5 times g prime of 2 minus 2 times 2. We'll find that, so then we'll plug in whatever g prime of 2 is in the table, which you can't see right now, but g prime of 2 is -3. And then the final answer is 5 times -3 minus 4, and we get -19. So yes, that is the end of the first page. Okay, so we have moved to the second page of the worksheet for number 17. And so before we start, I want to point out that both of these functions are in terms of x. And so what we are trying to find is the derivative of y with respect to u. And so let's get started doing that. So just write what's after the arrow. Okay, so we will rewrite it as dy over du is equal to dy over dx over du over dx. And this portion of the question is an alternate way of writing the chain rule. And so we will get -1 over 5 minus x times the square root of 5 minus x squared minus 1 divided by 2 secant squared x of 2x. And so, as you can see, this is basically the derivative of inverse of secant 5 minus x over the derivative of tan of 2x. And so, to help this make more sense, the original derivative of inverse secant is 1 over x times the square root of x squared minus 1. And so that's what we're doing here. We're just leaving the 5 minus x in the position of x. And then the chain rule we have to do is with the negative x here, because the derivative of 5 doesn't matter. So the negative x is negative 1. So we add this negative up here. That's the chain rule. And then the derivative of tan x is secant squared x. So that's how we get there. And then because of the chain rule, that's why the 2, we're multiplying times 2. It's just in the front, back here. So then we will simplify this, and we will get negative 1 over 2 times secant squared x, or 2 times secant squared 2x times 5 minus x times square root of 5 minus x squared minus 1. And so that is the final answer to that one. It's just a lot of, it looks a lot harder because it's a fraction, but it's really not that much harder. You're just taking the derivative of this function and the derivative of this function and writing it as a fraction, and then simplifying to get your final answer. And that is a 2x right there. It's kind of hard to read. I messed it up, but 2 secant squared of 2x, and then the rest of it. That's your final answer. Okay, so these last few questions are really similar to the first page, but instead of using the table like we had on the first page, we're going to use this graph. And so to start, we need to find the f, g, and f prime and g prime values. So I'm going to write those, how to find those here. So for the first one, f and g, for the f and g values, those are y values. Write that here. And then f prime and g prime values are slopes. And to find the slopes, you can do y2 minus y1 over x2 minus x1, or basic rise over run. But I'm going to write out the slope of these 4 line segments to help us when we are solving the questions later on. So just fast forward through this and we'll review what the slopes are. So the slope of this line segment, m equals -2, m equals 2 here for this one. The slope is -2/3 for this segment. And then for this segment, the slope is 3. And so this will help us later on when we need to find f prime and g prime values, just to have the slopes already figured out. Okay, so for the first question with the graph, we'll do it, we're solving them a lot like basically the same way we did the questions on the first page, or the first few questions on the first page, except instead of using a table to find the values to plug in, we'll use the graph up here. So we'll take the derivative of this function, which is p prime of x equals negative f of x times g prime of x minus f prime of x times g of x. And this is a product rule, so that's how we got here. And then next we will plug in 2. So p prime of 2 is equal to negative f of 2 times, so here, this is what we get when we plug in the 2. That's the new function. And then before we, sorry about that. Pretend I did not fast forward. before we can find these values, I'm going to go ahead and we're going to go ahead and write them out over here to make it easier to plug in. So first, we're going to find f2. So let's go a little bit to get these values, and then I'll explain how we found them. Okay. So f of 2 is equal to 2/3. So that's the y value of 2. F prime of 2 is equal to negative 2/3 because that's the slope here. G prime of 2 is equal to 2 because on the g of x line segment, the slope is 2. And then this is in our way. Sorry, this is going to have to be a little visible for the time being. Oh, just kidding. And then we'll plug those in and get negative 2/3 times 2 plus 2/3 times 4. And our final answer is 4/3. Okay, so moving on to number 19, we're going to do the same way. We're going to write out q prime of x and then take the derivative, this time using the quotient rule. So low d high minus high d low. And doing that, we will end up with 2g of x times f prime of x minus 2 f of x times g prime of x over 2g of x squared. And then we're going to plug in the 4, and we will end up with the function rewritten as this. So, so here you're just taking the 4 and plugging it in every time there's an x, and rewritten it looks like this. And so then next we're going to look at the graph above and find the values for all of the g of 4, f prime of 4, all of these values using the graph. So the first value we need to find is f of 4. So using the f of x line segment and the x value of 4, we get that the answer is 3. So f of 4 is equal to 3. Then we need f prime of 4. And so we're using the same point, but this time we're using the slope of this line where it intersects. So f prime of 4 is also equal to 3. And then for g of 4, we will be using the g of x line segments instead. So g of 4 is 4, and g prime of 4 is negative 2 because where it intersects, the slope of this line is negative 2. So we found those values using the graph, and so I'm just going to write them out here so it's easier for us to find our final answer. And then let's go back forward a little bit. So here we're going to plug in the values we found, and we will get 2 times 4 times 3 minus 2 times 3 times negative 2. You can't really see the negative 2, but there you go, you can kind of see it. It's there. And then 2 times 4 squared. And then this ends up being, sorry, gotta adjust my paper. And then we will get 36 over 64, which simplifies to 9/16. And that is our final answer for number 19. So for number 20, we're first going to find the derivative using the chain rule. So we will end up with g prime f of x times f prime of x. And then we will plug in the 4. So we'll do n prime of 4. And then g prime of f of 4 times f prime of 4. And so in order to find the values to plug in for this equation, we're going to need to use the graph to find f of 4, f prime of 4, and g prime of 3 we'll also need, which you can't tell we'll need that yet, but hint, f of 4 is 3, so we'll need that one. So we will, sorry, it's a little crooked. Oops, let's go back to the graph. Okay, it's a little crooked, but it still serves its purpose. So f of 4 is 3. F prime of 4 is also 3 since the slope of this line segment is 3. And then g prime of 3 actually does not exist because there is a sharp point right here. So where these two line segments connect, there's a sharp point, and we cannot find g prime of 3, therefore it does not exist here. So moving back down to our problem, we will write down those values we just found. F of 4 is equal to 3, f prime of 4 equals 3, and g prime of 3 does not exist because of the sharp point. So we'll go back and we will plug in these new values. Oops. Okay, well, fast forward a second. We'll plug in these new values. 3 times g prime of 3 is what we get. And since g prime of 3 does not exist, the answer to the whole question is does not exist, because you can't multiply 3 times doesn't exist, doesn't work. So you just get does not exist, D and E, for the answer to number 20. So here we go with number 21, the last question in our worksheet, and C prime of x is f prime of g of x times g prime of x. So it's just a chain rule, simple chain rule question. Then our value here is 0.5, so we will plug that in, and we will end up with this. So you plug in 0.5, where we have all the x's, and then the values we need to find, I'll write out over here. So g of 0.5 and g prime of 0.5, and then f prime of 1, which I guess we don't know we need yet, but you'll need it. So we will move up to the graph next to find these values. Okay, so the graph's a little crooked again, but we can find our answers. So first we need g of 0.5. So about here, and using the g of x line is 1. So g of 0.5 is 1. G prime of 0.5 is 2 because the slope of this line segment is 2. And then f prime of 1 is negative 2/3. So since finding f prime of 1, the slope of this line segment is negative 2/3, and that is how we get that answer. So now that we've found those using the graph, we'll write them out so we can finish the problem. And then we'll plug these values in. And so first we'll find g of 0.5 and g prime of 0.5. And so we'll end up with 2 times f prime of 1. F prime of 1 is negative 2/3. So we get 2 times negative 2/3 and end up with the final answer of negative 4/3. Can't completely see that. I'll move down a little bit. I'll try. There we go. So the final answer you get for number 21 is negative 4/3. So that's it. Thanks for watching, and remember that we have lots of calculus videos on our channel, so like and subscribe if you thought this was helpful. Bye.